On this, we already have a pretty good idea of this. All right. So I'll lecture first, then I'll hit homework questions, and if you need more time on the homework, totally fine. Cool? This is the unit circle, and I mean this is a really bad rip off the internet of the unit circle to fill out. But as we progress through, you're going to see it more and more filled out. So we've already talked about this. What quadrants of sine are positive for the unit circle and things like that? Where's cosine negative? So sine positive are, we just look at this. Okay, so this is quadrant 1, 2, 3, 4. Is everybody okay with all those?
The all stupid, yeah.
Yeah. All right, so where's sine positive? Well, that's 1 and 2. Okay? So this means, hey, where's cosine negative? Less than 0 means just negative, right? So where's cosine negative in 2 and 3? Cosine's positive in quadrant 4. Okay? Where is tangent positive? Well, definitely quadrant 1, because we're looking for it, because they're all positive there. And then tangent's also positive in quadrant 3. That's why you have ASTC. The ASTC refers to all of them, or sine and its reciprocal is positive in quadrant 2. Tangent is reciprocal in quadrant 3. And cosine in quadrant 4. Oh, jeez. My bad. I would have done for it. All right. And then you're going to come across the problems, and I know this was part on homework a little bit last night too. Identify the quadrants where sine is positive, so all students, and where tangent is negative. Okay, so sine is positive here and here, and where is tangent negative? Here and here. Okay? And that's basically how you're looking at that. So that's talking about region 3 and region 1 are the two where tangent is positive. Region 2 and 4, it's negative. So you're just identifying the reason. And they have the and sign. So it's like, where is sine positive and tangent happens to be negative? What's the only overlapped region I'm talking about right here? Yeah, it's the S region, which is region 2. Okay? Can I move on? Okay, thank you. All right, so now, this is more of that filled out. Now, I'm going to tell you that this is great to know. And I know this is on your sheet, but it's dark, so it's kind of hard to see. So there's a couple of things that become kind of a thing to remember, a mnemonic way of thinking. So first thing is everyone okay that this is an ordered pair?
Yeah.
Okay, so this is a point, a point, a point. We have points all the way around. By us doing it as ordered pairs, that means that the radius all the way around my circle is 1. And the big key on that is, there's a couple patterns that you might see. So, ready? Let's start just with the y value. You with me? 0, 1, root 2, root 3. Okay? So look at this. The y value, 0, 1, root 2, root 3. Watch this. If I start with the x value and count this way, 1, root 2, root 3. They're in order. Okay, so I'm just pausing on that for a second. So again, if I start at the 0 here, and I start making my progression, it's like going 1, 2, 3, but it's root 1, root 2, root 3. It's like, yeah, but it's 1. Yeah, what is root 1? 1. Yeah.
So is this like something we could add to our note cards and memorize?
Yes, and I actually am going to hand more today, and again, it's up to you. And one, I'm so excited that some of you have made those note cards. I mean, I'm telling you, it's going to help with so much. So from here, we're saying, okay, now what are my my value. So cosine of 2 pi over 3, well, 2 pi over 3 is right here. So this is a 60-degree angle right here. So the cosine is which value, x or y? X, it's alphabetical, right? So it's negative 1/2. Oops. Stop eraser. And then someone had a question on this, and this will make, I hope to clear this up right now. So let's find 11 pi over 6. 11 pi over 6 is down here. Okay? So tangent is what? Y over x. So I have negative 1/2. Negative 1/2 over root 3 over 2. So I have a fraction over a fraction. That means I want to take the bottom fraction and multiply it to the top, but I'm multiplying by the reciprocal. So the math that I'm doing here is this. Is that okay so far? This cancels here. So I get negative 1 over root 3. If you rationalize it, fantastic. If you leave it like that, cool. I'll keep it. It's all good. If you wanted to rationalize it, it's negative root 3 over 3. Same idea. And then sine of pi. Where's pi? Well, pi is at 180 degrees. Sine is what value, x or y? It's alphabetical.
Y.
It's y. 0. Done. Okay? And again, I just went here. Sine of pi is right here. My y value is that. My y value is sine. Okay? Okay, so you can also use the unit circle to find angles. Okay? So what angle has a cosine of 1/2? So let me ask you this. Cosine is what value of the point? X or y? X. So I'm looking where I have an x value of 1/2.
60.
So 60. Where else? That's negative 1/2. That's negative 1/2. Oh, positive 1/2. 300. Okay. Should we put them in radian amounts? Sure. So that's pi thirds. 300 is
Pi.
what?
5/3 pi.
5/3 pi?
No, 5 pi over 3.
Pi, same thing. Cool. And then it says, hey, what angles have a tangent of negative root 3? So let's think about, or just regular root 3. So we have to think about, okay, first off, it's positive. So where is tangent positive? 1 and
4, 3.
1 and 3. Okay, so tangent is positive in 1 and 3. So tangent is y over x. So tangent's y over x. So I need my y value, what's on top right now, to have my root 3 as top. So what has the x value of root 3?
30.
30? So this will be my numerator. This one would be my denominator. If I do that, I multiply by reciprocal, so I get the root 3 on bottom. Okay? So then the other one with the root 3, that's positive, is down here. So are we at what? Right there? Negative over negative is?
Positive.
This is going to allow me to have... I just went backwards. Oh my gosh, I must be... This is a 60-degree angle. I pointed to it, and I circled the wrong one, and I'm so sorry. Okay, so if I have root 3 over 2 times the reciprocal of the denominator, which is 2 over 1, that's going to happen. So this is the one we're looking for. So that's a 60-degree angle. And then I'm also looking for the root 3 over 2 and the y. So it's down here. So that is a 240-degree angle. And again, I could go ahead and put those and make them in radian amounts. Okay? And then formally, we write that. So all that is, hey, what angle has cosine being root 2 over 2? 45. And? So I have 45 degrees. And why is there a second angle?
Because the negatives cancel out.
The negatives cancel out. So all students take calculus. So down here in quadrant 4, we have another 45, so we have 315 degrees is my other location that cosine is positive. Quadrant 1, quadrant 4 is positive. So both of those places, so there's two answers that happen here. Where is tangent -1? Well, tangent was y over x, agree? Which means I need to have a value. I have to have the same fraction over itself and make it negative. So where is tangent negative? So all students take calculus. Where's 2 and 4? 2 and 4. So what values would be the exact same fraction?
45.
So
135.
So 135
315.
and 315. And some of you are saying, wait, where did that just come from? Remember, I'm going y over x. So if I had the exact same y value over the exact same x, doesn't matter if one's negative or one's positive, I'm looking to where I can make my answer -1. And then, where is sine negative? What quadrants?
3.
3 and
1. 4.
3 and 4. Okay? 3 and 4. So down here is where we're looking. Sine is x or y? Y. So which one has a y value of -1/2? 210 and 330. Where are we at?
Read out one more page.
One more? That's it? That's my last one right there? There's no more? Okay. All right. So there are two restrictions that take place here. We want to find theta, and theta happens to be happening between pi over 2
So 90
and pi.
and 1.
So this is saying, hey, I want this restriction to take place. So I'm looking right here.
Second quadrant.
Second quadrant. Okay? Can cosine be negative in the second quadrant?
No.
Yes.
Yes.
Sine's positive, so cosine's negative. So cosine is x or y?
X.
X. Where's my -1/2 x value?
120.
It's 120. Okay?
Find the these on the circle.
Uh-huh. So tangent theta, so that's y over x. So let's think about this. If I have a y over x, and I have a √3 here, that means I want my original √3. Let's see if this works. If I have √3 over 2 over 1/2, nope, that's just √3.
150.
I need the √3 on bottom. I need this. So when I do the reciprocal, that becomes 1 over 2 times 2 over √3. Cancel, so I get 1 over √3. Rationalize that, multiply top and bottom, so I get √3 over 3. So I need to have my x value be √3 over 2 in that quadrant.
No.
150. There you go.
Negative.
Do what?
Whether you want it negative. You want positive or negative? Gotta keep it technical in case it.
No, we're just in quadrant 2.
Yeah, 150. There's a negative √3 over 2. You looking for a negative? Or?
Yeah, because that was a negative there. There's a negative sign right there. Yeah, we're good. And then sine is x or y. So I'm looking at quadrant 2. Is sine positive in quadrant 2? Yeah, because all students.
Yeah.
Okay. So what y value has a √3 over 2? 120.
120. Nice, Sam.
Got the delay. All right. So I have another sheet, and I'm making this one optional. I didn't put it on cardstock because I only had to make 500 copies. I mean, this is one ream of paper.
You have 500 students.
One ream of
No.
paper.
So
What's a green?
I just want you to.
500.
So these that look like this, these cards, it'll say sine in degrees, and then on the other side it says sine in radians. So a really good thing if you're able to do it is if you walk around the unit circle. So you would start with 0 degrees, 0 radians. Okay, and then it has the cosine and the tangent. And then you have the next one, that's the sine of 30, the cosine of 30, the tangent of 30, and then the radian equivalent, so 5/6. And then you have 45, and then you have 60, and then you have 90, then you have 135. Gotta keep going. I forgot my numbers going around. So long and the short of it is, I'm going to leave this up to you. One sheet here has both sine, or degrees and radians for sine, cosine, and tangent. Does that make sense? So if you wanted this, so I'm leaving it as your choice, you would need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pieces of paper of this. Okay? Because each piece of paper, so this one will go with 0 degrees. This one goes with 30. This one goes with 45. This one goes with 60, where you have to fill it out. So I'm going to leave it up to you if you want to do that. I think it'd be extremely helpful if you did do it, but I also think some of you are starting to see it pretty quickly. Okay, let's go over questions on homework from last night. It was C.
This would have made so much more sense.
It was
if
D.
we had these notes.
Yeah, actually, I don't remember.
Sorry.
That's okay.
It's your fault.
It is. You want to know what else is my fault? Oh my gosh, I got yelled at by a parent last night because his kid was wrestling, and because I asked them, can you please walk through the gym to go to the wrestling room? This guy used the F word as 5 parts of speech when talking to me last night. And I looked at him and said, sir, I have no idea who you are, but I will tell you this. I'm going to be contacting our school police officer right now, and I'm going to have you escorted off campus, and you're going to be trespassing. You'll never be welcome on this campus again.
I never knew Stirrup was a snitch. Just kidding.
Well, if I wasn't a teacher in that school and someone talked to me out there, he would have met, 1, 2, 3. But I'm just looking at this guy going, and now here's the thing. Here's this 5-year-old kid. And this is all I said to him. Sir, I need to keep this door locked for the safety of the students. Boom! Blew up.
You should have punted his kid.
But I'm just like,
Where did you come from?
that's kind of my sense of humor too.
I didn't need to wear cowboy boots and stuff because in my heart I'm a cowboy.
Cowboy.
Congratulations.
My last name's Stirrup, so I just figured that was cowboy enough.
I grew up on Joe Prince and snitching.
Alright, so
Same thing.
hopefully I don't miss anything. Hey, one of these went around and it had a no name on it.
That was mine.
No, that one had no name.
No, it's not mine, but I'll take it.
I'll set it back around here.
Mine. Yeah, that's mine.
Alright, put your name on it. Alright, questions from last night's homework.
Anything 31?
Can we just do it with 2?
Number 2. Oh, number 2.
Fill in number 2.
I need 31 and below that. 'Cause
31.
all of the secant and
Okay. Which one was it? Was it C or D? D? D. And 31? Okay. Cosecant of 2 pi over 3. Okay? So let's think of this first. It's kind of hard to think what cosecant would be because we haven't talked about it. But its reciprocal is sine, right? So this is going to be the sine of 3 over 2 pi, which kind of looks weird. Okay? So I'm going to take a look at what this angle would be first. So where on our unit circle is 2 pi over 3? Do we have any? What's that? 120? So it's 120 degrees. So think about this, 120 degrees, which is, what in radians? 2 pi over 3? That's 2 pi over 3. Those are the same in itself. All right, so let's think about this. Here, that's the 60. What is that point right there? What is that exact value? And what? Root 3 halves, okay. All right, so sine goes with y, right? So my y value is this. So the sine, I don't want that. The sine of that angle is, of the angle that they wanted is going to be root 3 over 2. So the cosecant is just going to be, of the angle, is going to be 2 over root 3. And it, that's what I need. Yeah.
Like in general, when would it be undefined?
Undefined is going to happen at on the x and y axis. So tangent at 0 and 180 works. It's just 0. Tangent at 90 and 270, is undefined. Cotangent is the flip over. So at 0 and 90 or 0 and 180, it's undefined, and it's 1 here and here. All right. So what else should we take a look at? Which one? 30. All right, 32. We want the secant of 0. Okay, so I want us to think of this. That is, secant is the reciprocal of cosine, right? Now this is where we have to be careful. So this is 1 over cosine of 0. Okay, we got to be careful on this. So on my ordered pairs, cosine goes with which value? It goes with x. Okay, so cosine goes with x. So the cosine of 0 is, where is cosine 0? Here?
Yep.
And here? Okay, now think about this. If secant is 1 over cosine, and if I were to do that, if I were to do the inverse of 0, it's not going to work. It should be undefined. Okay, now, this is what we're going to see. So this is where we're going to get into this starting in the next day or so. Don't let this panic you. This is just a glimpse. This is a glimpse of your fear. Okay. 1.
It's like those visions in Final
Okay.
Destination where they
So if I want to graph the cosine graph, okay, watch this. This is how easy this is to do, and we'll cover this more tomorrow. So cosine is my x value. So here it's at 1. Here it's at 0. Here it's at -1. Here it's at 0 and back up. So this is what the cosine graph actually looks like when I graph it. Now this is why this one is undefined. Wherever this crosses 0 is an asymptote, for its reciprocal function. Okay? And the secant graph I'll do in black. This is what the secant graph looks like. So that's why it's undefined. So the secant graph, this is your cosine graph, it's your parent function. The secant graph, you draw asymptotes wherever it crosses the x-axis. So those are those pinks. So this is an asymptote up. This looks like a parabola. It's not really a parabola. It appears to be, but it's not. So it just continues going that way. Let's pull up. That's why I want the calculator to load fast. All right. So don't change this on your calculator. We're in radian right now. It's good. You go y equals.
It would be good if we told us this morning.
What are we doing? His deep. If he was doing like lucid dreams, like his tone.
All right. There's my sine curve.
Wow, people are telling us all.
That's gorgeous. Let's do my cosine curve, or my 1/, cosine x. Because I don't have a secant button on my calculator. So the red is the cosecant curve, blue is the cosine curve.
Hey, Stirrup,
It repeats it.
you got a meeting tomorrow morning?
Yeah, it's art right there.
How's it going?
We got homework?
You read, so Shannon, raising or repeats, I can keep going around the circle, right? And then the ones in the negative, I'm going clockwise around the circle. The ones in positive, counterclockwise. All of them. 1, 2, 4, 7. I have a meeting at 7:30 tomorrow. Come before then if you need to. You guys, if you're done with your homework, you can drop it off on the orange folder if you need more time. And guys, girls, let's get you to do worksheet. Worksheet E, every other even. If you're not sure about that, just do all of the evens. If you're not sure what evens are, do all of them, and I'm sure you'll nail it. Good night, you guys, girls. Have a good day. Take care of one another. Wave to the camera on the way out. Yes. Yes. Just find out which one. So if you want any of those, grab. It's like 16 of them.
That's like a different language. I don't even know what to put there. So.
Radians? Yeah. 0, pi halves, pi thirds.
12, 4, 8.
We have these small.
Yeah.
What the heck?